Okay, science students, welcome to the second screencast that I put together, this one dealing with mixtures and elements and compounds. Before we get into reviewing and learning some new material, I wanted to share with you the purpose of having these videos accessible on Google Classroom. If you need help with homework, if you want to review for a test, if you need help with lab questions, this is a portable tool that you can utilize and you can access whenever you need to. So in addition to your notes, your book, worksheets or handouts you might get in class, this is something that you can independently use in order to get the extra help that you might need. Lately we've been going to the computer lab so that we all get an opportunity to log on to Google Classroom and view these videos. But in the future I'm hoping that you can independently view the videos on your own and then come to class prepared, or come to class being even more of an expert on what it is that's discussed on these videos. So anyway, the review of the mixtures. We've been talking about this the last 2 days this week in class. We have basically two categories and then a few examples that fit under a specific category. We learned that if a mixture is made where you have two poorly mixed substances, and you can easily identify those two materials, we call those heterogeneous. For example, we have paper clips and water. And we saw an example in today's activity too, where you saw a heterogeneous mixture. We'll look at that in a second. If you have something that's very evenly mixed and it has the same appearance throughout, we would call those homogeneous mixtures. And all three of these photos that we viewed a few days ago are great examples of homogeneous mixtures. You have the colloids like the shaving cream, solution, and this iced tea, which is also technically a solution. Now, the most important part to remember about mixtures is that they can be created and they are separated through physical changes. There's no chemical change involved in the creation, or if we needed to separate either the solute from this solution or this paper clip from this mixture with water, we would use physical changes to do that. We're going to have a lab on Monday that would demonstrate that important concept. Today we looked at, during one of our stations, 4 different examples of mixtures from left to right, and I had labeled them on the bottom. We were looking at seltzer water and sand and water and sugar and some hair conditioner. I hope that you identified the first one as a solution, and the second one, of course, was a heterogeneous mixture. That sand will not dissolve in the water. The third one was another solution, and the fourth example was a special kind of homogeneous mixture, which was called a colloid. Now, maybe you were looking at the labels that I had written on the bottom of those papers underneath the familiar or the common name for the material that was in the beaker. And you may have asked yourself, well, what is that for? What are those symbols? And that's the main topic of today's screencast. So basically, if you think about matter, okay, the material that all of these liquids, solids, the paper, the table, the air, the smallest form of any element is something that's called an atom. And I have been using this circle as a representative for this atom. Do atoms really look like little circles? No. But if you think back to maybe some lessons that we've done in the past, like this diffusion lesson way back in October. And here's another diffusion slide that I shared with you a few months ago. And even here, you have been exposed to, I've been trying to subconsciously familiarize you with these little spheres as being models for atoms. So that's something very important that you need to kind of grasp right now. This is the smallest particle of any element. And for convenience sake, we'll use these little circles to represent atoms. So there was a word in there that I didn't know. It's something called an element. You might be familiar with that word, you might not. A great definition for what an element is it's a pure substance. It's a specific flavor of an atom. And the flavor of this particular atom, the element that this little blue circle represents, is something called oxygen. Now, when I think of flavors, I think of maybe ice cream, like you're going to an ice cream parlor, you're choosing flavors to put inside of your milkshake or your ice cream cone. Now, for elements or for matter, it's like a really big ice cream parlor where you have so many flavors, you have so many elements, you actually have more than 100. And in your textbook, there is something called the periodic table of elements. And we're going to be exploring this extensively when we start talking about chemistry. We're going to learn that some elements have properties that make them not reactive. Other elements are extremely reactive. And you guys are going to be able to use this tool so well that you can look at where the element is and determine how reactive it is. So I hope you're excited about that. I definitely am. So let's take a look at maybe some examples of elements. So we have these letters in each of the boxes. Some of the boxes have one letter, some of the boxes have two letters. These are called chemical symbols. They're abbreviations. They're like the initials of the element that's listed underneath. And you could probably see more closely in your book that the long form name of the element is written below. The chemical symbol is abbreviated very largely in big print. And then you have some numbers that are floating around that we'll learn about later. So my first question to you is hydrogen, and here's my atom to represent hydrogen, is hydrogen an element? So what you need to do to determine if something is an element is you need to find its symbol, its chemical symbol, the initials, using the periodic table. So I'm looking around, I'm perusing the periodic table, I'm looking for the chemical symbol H. And hopefully if you are perceptive, you have found that yes, hydrogen is an element, and it's located way in the top left corner. Hydrogen is an extremely reactive element that reacts with basically almost every other element on this periodic table, which we will see later. Let's see another one. How about helium? This is represented by a blue atom. Is helium, He, an element? So let me look for that chemical symbol H, lowercase e. I do see that some of these chemical symbols are both capital and lowercase letters. So I'm looking for capital lowercase e. Can I find that element on the periodic table? And I found it in the top right corner. So yes, H, lowercase e, helium is an element. How about another one? I'm looking right away at the set of atoms here, and it looks like there are 3 atoms that are combined for some reason. And the question is asking me, is water, H2O, an element? H2O. So I'm looking for the letters H and I guess a number, and I don't see any chemical symbol that has H2O in this periodic table. You will not find any block or any box in this periodic table with H2O in it, because water is not an element. Water is something called a compound. And a compound is a mixture of elements. A compound is a combination. It's as if you have an individual atom partnered with another atom. This happens to be a very simple compound where one molecule, one compound, is made up of 3 atoms. We might learn about some compounds that are more extensive, that have many atoms bonded together. A very important thing to remember or to understand now that this is the first time that we're really seeing the word compound. The only way you can create a compound and the only way that you can separate a compound is through a chemical change. A chemical change needs to take place that is permanent, where the chemical structure of this compound is changed and is rearranged. When we start learning about chemistry, we will see all sorts of ways that compounds can be altered and atoms can be rearranged. So just to give you a summary, and again, bringing it back to the start, there are some examples of compounds that we have seen and maybe subconsciously you were remembering them, because that is information that we're going to start using now. A compound can only be separated chemically, and a mixture can only be created or separated physically. I hope this helps. Take your time with the questions, and thank you for watching.